Hello guys, welcome back to my channel. As you know, my name is Likhith. So today I'll be explaining a topic from the subject Database Management System. So let's get on with the topic. So the title is Understanding Dependencies and Normal Forms, whose subtitle is Multivalued Dependencies, MVDs, and fourth normal form, 4NF. So let's get on with the introduction to dependencies. Dependencies in relational databases. Dependencies are relationships or constraints that exist between attributes, columns within a relation, that is table in a relational database. They define how the values of each attributes are related to or determined by the values of other attributes within the same relation. So, the importance of understanding dependencies. Understanding dependencies is crucial for proper database design, data integrity, and efficient query processing. They help in identifying and resolving data redundancy, which is repetition of the same data, that is copy if there exists the same data in different instances, so it allows removing of those data. So that's what I'm trying to say here. And anomalies and inconsistencies. By enforcing dependencies, we ensure that the database accurately represents the real world relationships between data entities. So, the types of dependencies. Functional dependencies or FDs. Full definition stands as functional dependencies are relationships between attributes within a relation such that the value of one attribute uniquely determines the value of another attribute. Example, in a relation R of A, B, C, if A tends to B, if A is related to B, it means that for every unique value of A, there is only one corresponding value of B. That is, if we have some data that is in the relation or table R, which contains A, B, C, and if A is related to B, it means that for every unique value of A, there will be only one corresponding value of B. So that's what we are trying to do in functional dependencies. And it's important to know that functional dependencies help in identifying keys, determining normal forms, and ensuring data integrity. Multi-value dependencies, whose definition stands as multi-value dependencies represent constraints between sets of attributes in a relation, indicating that certain tuples can be split into multiple tuples. That is, as you know by the definition of tuple, a tuple stands for a specific row. So a specific row can be split into multiple rows. So that's what the meaning of multivariate dependency stands for. So in example, let's consider with an example. If there is a relation in a relation R of A, B, C, if A, B is related to C, it means that for any two tuples T1 and T2 with T1 of A, B is equal to T2 of A, B, there must exist a tuple T3 with T3 of A, B is equal to T1 of A, B and T3 of C is equal to T2 of C. So it's just like if there exist two tuples, which is T1, if T1 is related to T2, and it it means that there must exist T3 which is also equal to T1 and T3 of C which is also equal to T2 of C. So let's move on to the importance. So what is the importance of multivariate dependencies? The importance of multivariate dependencies is they help in achieving fourth normal form, that is 4NF, and addressing certain anomalies in database design. So what is fourth normal form or 4NF? Fourth normal form or 4NF is a normal form used in database normalization to address certain anomalies that arise from multi-value dependencies, that is MVDs. What are the characteristics, you might ask? So the characteristics of fourth normal form or 4NF is a relation R where is in 4NF if every non-trivial multi-value dependencies, that is X to Y, where X is a super key. This means that 4NF eliminates or reduces redundancy and update anomalies caused by multi-value dependencies. So it's a upgraded version of the multi-value dependencies where the redundancies are reduced and anomalies caused by multi-valued dependencies are updated. So let us consider with an example. Consider a relation R of A, comma B, comma C with multivariate dependencies where A is related to B, comma C. If A is a super key in relation R, then R is in 4NF because multivalued dependency is satisfied. However, if A is not a super key, then R is not in 4NF and decomposition is required to achieve 4NF. So, what are the other types of dependencies? So, the other type of dependencies are joint dependencies, which represent constraints where certain tuples can be reconstructed by joining other tuples. Then, full dependencies, a type of dependency where one set of attributes is functionally dependent on another set of attributes without any extraneous attributes. Then, transitive dependencies. It is a type of functional dependency where a non-prime attribute is functionally dependent on another non-prime attribute through a transitive relationship. Other specialized forms of relation or forms of dependencies may arise in specific scenarios, such as partial dependencies, which occur when non-prime attributes are functionally dependent on a part of a composite key. So let's conclude this topic. So let's get on with the summary. Dependencies, including functional dependencies, FDs, and multi-value dependencies, MVDs, are essential concepts in relational databases. Functional dependencies define relationships between attributes, while multi-value dependencies represent constraints between set of attributes. Understanding these dependencies is crucial for proper normalization, data integrity, and efficient query processing. So this ends my presentation. Thank you for watching.